Thank you ACM India for this recognition and TCS for sponsoring the award. It was a nice prize money associated with it. Thank you so much. So let's get started. Again, I'm Priyanka. Hello. Hi everyone. And today I'm going to talk about how AI and formal methods hand in hand together can be used for automated synthesis. Like back in 1940s, IBM President Thomas Watson said that there is a room of about 5 computers. And today, we are imagining, or I would say rather living in a world surrounded by complex computing systems. These systems might be helping us in a healthcare. They might be performing surgeries for us. The system might drive themselves while we sit back and relax. These systems are there to assist us with whatever and whenever we need. And we are relying on these systems to make crucial decisions for us. What is the key quality that we want in these complex computing systems around which our life revolves? We want these systems to be trustworthy, right? We want to trust these systems that they are going to be accurate and reliable in all possible scenarios that they are going to face. How do we ensure that the systems are trustworthy? What are the trustworthy techniques? And these were the directions which I explored. Was one of that was we can achieve this trust via certification. Certification via formal verification and rigorous testing, ensuring that the system meets its requirement. Let's take a particular scenario. So I assume for the ACM India and ARCS to organize this event and to come up with the schedule was a difficult task. So I'm assuming that they came up with a scheduler to arrange the talks and the schedule automatically. So now we have a system which takes this input, like what are the time, how many talks and all, and then give us the schedule automatically. But suppose my host, Shivashish, where is he? I can't see him in the audience, but suppose Shivashish has this unique requirement that no 2 seminars should be consecutive. I don't know why my slice is cut on that side. No 2 seminars should be consecutive. He might like coffee breaks in between. Now he has a system in his hand and he wants to check whether the system meets this particular property, which is no 2 seminars should be consecutive. So we would like to certify that the scheduler does not arrange 2 seminars consecutively. That means it meets the property that we wanted it to meet. So that is the certification. In general, certification is all about have we made what we were trying to make. So system, I'm calling it very broadly. It can be hardware, software, any system, and we would like to check whether it satisfies certain properties. Let's abstract it out. So system over input I, output O. Properties over input I, output O. The question that we are asking, is it always the case that the system satisfies the property? Or contrapositively, can it be the case that the system do not satisfy the property? And to answer this kind of questions, we can rely on the so-called era of automated reasoning, right? We can rely on SAT solvers, which says that it solves this problem of Boolean satisfiability, which says, given a Boolean formula, is there any solution? Right? Just to ensure that everybody is on the same page, the Boolean formula may look like this. Toy example, x1 or x2 or x3. Why I am calling it Boolean? The domain is Boolean. This x1, x2, x3 can only take 0 and 1 value. So now, under this particular assignment, when x1 is 1, x2 is 1 and x3 is 0, you see that this particular example is true. This is a toy example. It can handle a very large, up to tens of thousands of variables and very complex formula. And we can rely on the progress in Boolean satisfiability to answer the question, can it be the case that the system do not satisfy property? That is one way to achieve the trust. The another way is to rely on correct by construction approach, which is, okay, so correct by construction approach. Correct by construction approach says that, can I design and develop the system which are correct inherently? So this verification check that we wanted will be part of our development cycle. We took the example of coming up with a schedule where we wanted to come up with a schedule which had this particular property of no two seminars should be consecutive. So now we would like to design or develop which inherently satisfy this particular property. So certification is what we were trying to make, and correct by construction approach is how my system is going to act based on the constraints. So these are the set of works that I have done in both the directions, and my PhD thesis, all the works were done during my PhD. But in my thesis, the correct by construction approach was the basis, and the works listed here were the part of my PhD thesis. And because it is about the DDA award, so I'm going to focus about what I've written in my PhD thesis, which is correct by construction approach, and that is the focus of this talk. Let us try to do it a little bit into the technical details. So when I say that the specification is provided to us, let us assume that it is provided in terms of logical relation. We would like to come up with a probably correct system, and how do we come up with that? That's what my thesis is all about. And this is, of course, joint work with my amazing advisors, Kuldeep Singh Neal from Georgia Institute of Technology and Shubhajit Roy from IIT Kanpur. So let's get started. The problem that we are looking into is the problem of synthesis, correct by construction approach. So what we have set of inputs x1 to xn, set of outputs y1 to yn, and we have given a specification that we are writing it here as relational specification psi over input x, output y. What is our objective? Our objective is to fill this black box. How are we going to do? This black box takes x as an input, somehow magically computes output y, such that when you put x and y back together into the specification, it satisfies the specification. Right? That is the problem of synthesis that we have. So this black box can be filled by any program, any circuits, and internal functions. And for this talk, we are going to restrict ourselves to the functions. So what is the problem statement? Given input x, output y, and a relational specification over input x and output y, we would like to come up with something that fills this black box such that x and y back together into the specification satisfies the specification. Let us try to write it down formally, right? Because formal verification. Before that, let us try to give you a quick example. So your specification can look like this. What is it? X is equals to y1 times y2. But y1 and y2 both cannot be trivially 1. So we would like to come up y in terms of x, such that when you put y and x back together in the specification, they satisfy the specification. Anyone in the audience, can you tell me how we are going to fill our black box? What will be the function of, how can we represent y in terms of x? No one? Good. So it is a factorization thing, right? Y is a factor of x. Now you look at it again. If you take x, say 12, and if my y is 2 and 6, that will satisfy the specification, right? So we would like, so how are we going to fill this black box? By a factorization algorithm that takes x as an input and gives you 2 factors, 2 non-trivial factors of x. And this is what we would like to do automatically. Let's try to formalize it. And this is where all my students now are very afraid that how do we formalize things? So let's see. Again, specification over input x, output y, and x can be x1 to xn, y can be y1 to ym. We would like to synthesize a function vector which says that come up with a function corresponding to each output variable, that is fi corresponding to each yi, such that this weird looking equation holds true. What is this weird looking equation tells us? It is telling us that there exists a value of y. If there exists a value of y, if this under which the specification is true, so if you replace y by the function that you have synthesized in the specification must hold true. That is what we wanted to do, right? For 12 as an input, if there exists a non-trivial factor such that the specification was true, whatever the factorization algorithm gave us, if we replace y by that, the specification must hold true. So we would like to synthesize this function vector automatically. We would like to represent y in terms of x. And in literature, this thing is called Skolem functions, and we are interested in synthesizing Skolem functions. Skolem function synthesis is a fundamental problem in computer science, and its history traces back long ago when it was studied by Skolem and Hubbard in 1930s. They did not look it from a computing point of view. It was more of a decision problem, whether there exists such a function or not. Even the history traces back to George Bull that says that existence and constructions of Boolean unifiers. So this is a fundamental problem in computer science. And if something is so fundamental, it is obvious that researchers have looked into it, both from theoretical sides as well as practical sides. So from practical sides, we have lots of work, from proof of extracting these functions from proof of validity, to quantifier instantiation, to knowledge representation, to incremental determinization. So what was the challenge? The challenge that we had was scalability. We were not able to achieve scalability. And we noticed, and I think everybody will agree with me, in order to deploy something in the industrial setting, we need to achieve the scalability. And that was the challenge that we took, that was the challenge that I took before my PhD, and we tried to solve the problem of scalability. So now, to solve this problem of scalability, we came up with Manthan. Manthan lies at the intersection of constraint solving, machine learning, and formal methods. It's a very nice fusion of all of these together, and the way we say in Indian mythology is that Manthan is all about churning. So they come mixed together, and then we churn the synthesis and the functions that we would like to have, right? So let's see how the architecture of Manthan looks like. So Manthan takes this specification as an input, and it first generates some data, because we wanted to use AI, machine learning, and for that we needed data, because all we had in our hand was this logical specification. We did not have any data in our hand. So the first thing for us to do to generate some data, and for that we took help from clustering sampling. Once we had the data, of course, the next obvious step was to generate the candidate functions, and with the help of machine learning. And once we had the candidate function, we were not happy, because the candidate might be 99.999% correct, but we wanted something that is indeed the Skolem functions. The weird looking equation that we saw in the beginning, we wanted a function to satisfy that particular equation. So we had to have something to verify whether the candidate are indeed the Skolem function that we were looking. If not, we had to go into a repair cycle. And this verification and repair was done using formal methods. Hence, it's a fusion of constraint sampling, machine learning, and formal methods. And ladies and gentlemen, this is Manthan for you. So let's try to go into a little bit of technical details. I know that audience is from the different backgrounds, so I will not deep dive into the technical details. It will be very high level. Please stop me wherever you feel like. So the first step for Manthan was to generate the data. I said that Manthan is going to use constraint samplers to generate the data. But what are constraint samplers? What do we mean by constraint sampler? You remember at the beginning of my talk, I talked about the Boolean satisfiability, which was taking a Boolean formula, giving us the satisfying assignment. What if I want lots of satisfying assignments? One way is to call that whatever the solver we have at the back end, again and say that, oh, one solution, give me another solution, give me another solution, right? But that is again not scalable. And we took up the challenge of scalability. So, for that, we have constraint sampler. What is a constraint sampler? It takes the specification as an input and gives you randomly uniformly generated samples from the solution space. So, you can say that, give me 5,000 samples and in one go you will get 5,000 samples. That is the power of constraint sampler. So, this big round that you are seeing may be the search space of the formula, and then small dots are maybe the satisfying assignment, the assignment under which the formula is true. And the constraint sampler will sample these satisfying assignments for you. So, how does it look like? Maybe our specification look like this, right? So, if you look into, and this might be the data that was generated by the constraint sampler. If you look into this data, each row of this table is a satisfying assignment for this formula. What do we mean by satisfying assignment? If you put x1 to be 0, x2 to be 0, y1 to be 1 and y2 to be 0, you see that this formula is true under that assignment. And that's how we can generate more and more data by the help of constraint sampler. Once we have the data, we wanted to use machine learning to come up with the functions. And when I say machine learning, it's just basic decision trees. We are using decision trees, simplest possible algorithm to come up with the functions. Why we chose machine learning and why we chose decision trees? It's easier for us to represent something in decision trees. It's interpretable, right? We see what is going on inside. It's not a black box for us. Hence we chose the decision trees. And we view it as a binary classification problem. Suppose we wanted to come up with a function for y2. What we can do? x1, x2, y1. The valuations of these can be our features and the valuations of y2 can be our label. And now pass it to a decision tree algorithm and get your function out of it. Similarly for y1. So that's how we can generate more and more functions with respect to each y. So once we have, okay, so here is an example. Suppose this is the data that we have and we would like to come up with a function with respect to y1. We might get this as our decision tree, and from this, how does our function look like? All the path that leads to leaf 1. So if you look into the P1, it's x1 is 0, x2 is 0, that is leading to the 1. And another one is x1 is 1 and x2 is 0. So it's a disjunction of all the path that leads to leaf node 1 will be our candidate function. So once we have the candidate function, the next step was to verify whether the candidates are indeed the column functions that we wanted. So we need to have a certification check there. If they are indeed the functions that we wanted, we have our functions and we are good to go. If not, we have a counter example. What is this counter example is going to say? That for this particular input, whatever you are synthesizing does not satisfy the specification. That's how your counter example is going to look like. So once you have a counter example, you try to extract out the reason what is the reason why the synthesized function is not able to satisfy the specification. And you extract out that reason and then prepare the candidates using that reason. And this loop continues until our candidates passes the verification check. Just one slide with equation, I promise. That is this slide. Because I wanted to share that the Boolean satisfiability and the SAT solver, the constraint solver, can handle. They were the key thing because of which we were able to to achieve the scalability. And I wanted to say that not the toy example that I just showed is that's not the scope within the SAT solvers. They can handle more and more and more complex formulas just like this, which says that the specification is true, but the synthesized function, if you replace y by that synthesized function, specification is false. So this is like a error formula. It's a certification check that we have. We pass it to the SAT solver. We say that, is this formula satisfiable? If the SAT solver says, no, I am not able to find any assignment for which the specification is true, but the synthesized function is not able to satisfy the specification, we are good to go. We have satisfied, we have proved that whatever we have synthesized is indeed this column function. If not, we have a counterexample to fix. So this is how our formal method based repair iteration look like. We call a SAT solver to check the satisfiability of this particular formula. If our SAT solver says the formula is unsat, we are good to go. If the SAT solver says that no, we have a counterexample, we use that counterexample and ask for the reason why this counterexample exists. Use that reason to repair it. And this loop continues until we have the functions that we wanted. And that's Manthan for you. So what is Manthan? Again, take the specification as an input, generate the data used with the help of constraint sampling, learn the candidates using decision tree, verify the candidates using SAT solvers. If the SAT solver says unset, good to go. If SAT solver says SAT, extract the reason using unset code and repair. This is the architecture of Manthan. Okay, before discussing about Manthan, I mentioned that we took up the challenge of scalability, right? So let's see if we were able to achieve something in that direction. The thing that you are seeing on your screen at this moment, this plot is called cactus plot. On y-axis, you have the number of benchmarks, which was 609 for us. On x-axis, we have time in seconds. These were the state-of-the-art tools before Manthan, SCADIT, VFS, and C2SYN. And the state-of-the-art was SCADIT, which was able to solve 280 instances out of 609 benchmarks. Each point here, each point x, y, says that a tool is able to solve y many instances in x many seconds. So where does the Manthan stand? This is the Manthan for you. Manthan is able to synthesize functions for 509 instances out of 609, which is a jump from 280, which was the state-of-the-art prior to Manthan. So that's my PhD about. So here is my journey in synthesis. So we started with this data-driven approach, which got published in CAV in 2020. Then we had this quest for scalability, and we came up with another version of Manthan, which is currently the state-of-the-art, and that got best paper nomination in ICCAD. Then we wanted to show some equivalence with respect to program synthesis that got published in HCAR. And then we lifted it for a generalizable category, which is modular design, which got published in that date 2023. Looks very interesting, right? Every puzzle's fit perfectly into it. Her PhD was like smooth walk. She was able to do everything perfect. Everything is perfect, right? Most of you are students. I am hoping graduate student, PhD students. And you must be thinking, she is an exceptional. She did everything. I am not able to do that. So, once we were able to come up with the first version of Manthan, we were not able to go anywhere far from there because all the existing state-of-the-art tools were not able to give us the scalability. The first thing that we were thinking about was constraint sampling, right? We were generating the data. And all the existing tools were just not giving us the good data. And we all know machine learning is what about? Garbage in, garbage out. So if the data is not good, then we were not able to scale at all. So what did we do? I was like, okay, we have to come up with our own samplers. What else we can do? If we don't have existing sampler, we have to design our own sampler. And that's what we did here. And we just change in this underlying sampler, we see a lot of improvement in Manthan. So one takeaway sort of thing, be in charge of your own project, be in charge of your own work in your PhD. Whatever it is, if you need to develop new tools, develop it. If you need to open that tool up, open it. Whatever it needs to take, you need to do that. Yesterday during my panel discussion, there was a question that, oh, we have lots of API call, why do we need to take care of the programs and why do we have to learn about the programs? API calls is generalizable, right? It's not specifically designed for your objective. So please take in charge of your work, learn how to do it, open up the tools and go inside the tools if it is needed. Again, I was talking about my PhD journey, right? So this was the email that I sent to my, this is the email that I sent to my advisor, Professor Kuldeep, back in 2019, even before my first paper got published. And the title of the paper, email was Need Help. Okay. And I will read up the details which I wanted to tell is that never had the courage to open up with you. I'm slow as compared to your other students. I'm not able to cope up with it. I always think that you will find all of this foolish. Right? My PhD journey was the perfect, all puzzle fit, no? I was able to get lots of best paper awards. Everything was perfect, going perfectly fine. That is the reality. I was thinking that I'm not able to do, it was all in my mind until I talked to Kuldeep about it, and it all thanks to him that he gave me the confidence that I can do it all. It was all in my mind, that's what he told me. So one lesson for the PhD students out here, please communicate with your advisor whatever the problem you are facing. Your advisor might have doctorate degree, doctor of philosophy, but they don't. As far as I know, they will not be able to read your mind. So you have to communicate with them. You have to tell them your problem. Then only they will be able to help you out. They will be able to take you out from your whatever you are feeling at that moment. Another, for early career researchers like me who might be going into mentoring the new students, please have empathy and kindness. The way my advisor treated me and the way he handled me is the reason I did not quit my PhD. And I'm here in front of you all, I'm here to talk about my PhD journey. I'm mentoring students now. So please have kindness and empathy with your students. And students, please discuss your problem with your mentors and advisor. So that is one thing. The second was the first rejection. So after a lot of time, so I joined my PhD in 2017 and I submitted the first work about Manthan to TACAS 2020, which is already approximately 3 years into my PhD program, and my first paper got rejected. And again, you saw my last email, I was anyway at the edge of quitting PhD, and then this notification came that your paper did not go through. And again, the good advisor that I had, I was super lucky to have my Kuldeep and Shubhajit as my PhD advisor. So this is the email that Kuldeep wrote to me. So we had a sort of a tradition in our group that whenever any student, graduate or PhD student, submit their first paper, the advisor used to take them out for dinner and cold drinks, right? And after first rejection, we used to go out and celebrate the rejection. I don't remember celebrating any of my acceptance of paper with my advisor, but I definitely remember celebrating all my rejections with my advisors. So again, for early career researchers like me, please be with your student when they face their first rejection. It is anyway, like I had my first rejection after 3 into the PhD, and it was devastating at that time. And emails like this, which is more philosophical like my advisor is, but really helped me out with this. As I was saying, this picture is not clear. We used to go out for cold drinks. And this is one picture. I chose this specifically because both my advisor is part of this particular picture, Kuldeep and Shubhajit, and Shubhajit was visiting NUS for some time. And so again, try to build that good relationship with your advisor, because this is a very long journey. It's approximately 4, 5, 6 year long journey. And your advisor and your friends during your PhD time will see a side of yours which even your family members does not know about you. right? So they know how you're going to behave at your worst of your phase, right? So please spend some time, spend quality time with your mentor, with your friends during your PhD to have that safe environment where you can open up about your problems to them. And again, if somebody is opening up to you, have empathy. It is very difficult. It takes courage for someone to open up to you. Have empathy, right? So that's all from what I have done to I have got this to end of era and start of another. So I graduated in August 2023. I defended my thesis. This is a picture with my parents. I had to defend it in online mode, but I was lucky to have with my parents. So this is the picture with the day I defended my thesis. So PhD is done. But I thought now life is going to be super easy. I am going to be my own. I don't have any boss anymore, right? I can plan my day. I'm all good. So for those of you who don't know, I joined IIT Delhi as assistant professor right after my PhD. I defended in August 2023 and January 24 I joined IIT Delhi. And I thought that I'm going to plan my day. I will be able to divide time as per my own wish. So I said, okay, 70% now is the research, right? Because I have lots of ideas and I know how to handle this and everything. 20% I have to give it to teaching because I love teaching. Admin, grant writing, all 5%. And this was my plan when I joined IIT Delhi. And after 6 months, this is how it looked like, which is 40% teaching, 20% meetings and emails, random urgent tasks, which I even not even sure what, like some random things, or 15%, then admin work, grant writing, and then 5% for the research. And 5%, I'm being very generous enough. I did not want to write 1 and 2% here. I thought, oh, you will judge that she is a fraud. So I had to write 5%. So this was the reality that clicked in. Again, I'm still figuring out how to have a balance thing. I don't know. I have a student now. So the more and more meeting I schedule with him, so that my meeting time still remains the same, but at least in that meeting time I have more research. So that's how the life in nowadays is looking like. A lot of admin work. We discussed yesterday in the panel about women in computing. One of the challenge that we are facing because of less women in academia, unfortunately, is that we have to, the women, whoever is there, have to be part of a lot of admin works to have some diversity in all the committees and everything. So that's another challenge that we are facing, but I'm not complaining. I'm happy about it. No issues. So this was the reality for me in the last 6-7 months. What I'm doing in terms of research nowadays, again, synthesis was core to me, right? I did my PhD in synthesis, so I'm looking into the one aspect, one direction in synthesis, in which we say, do we really need to come up with a system that must satisfy all the constraints? Can we have some gradation among the constraints, saying that some constraints must be satisfied and some constraint we can satisfy as much as possible? And this is the thing that we call satisficing synthesis, where it is applicable, suppose an autonomous vehicle. The hard constraint will look like not hitting a person, right? That's for sure. But soft constraint can be acceleration change, be in the lane, and so on and so forth. More realistic example, admission system. We might have to train over the other institutes' data and so on. So that might be our soft constraint, but individual institute have its own policies. So that can be our hard constraint. And we would like to come up with a system that have guarantees over the hard constraints, but try to satisfy as much as possible the soft constraint. So this is one direction which we are exploring at this moment. There's a lot of other direction in the synthesis, interactive synthesis, and so on and so forth, which I am exploring. I will not go into the details. I wanted to show this, that even though my PhD mostly was with respect to the synthesis, nowadays, as we all early career researcher will agree with me, is that we just can't continue with what we used to do. We have to diverge a bit, we have to make collaboration with our own faculty colleagues at the department and so on and so forth. So I felt comfortable in saying that I like to have this fusion of formal methods and AI, and wherever this fusion is applicable, I feel that I can contribute. So these are the direction which I am currently exploring with my colleagues at IIT Delhi. which is from fair resource allocation, information leakage, interpretable learning, neural network verification, circuit synthesis, and so on and so forth. So these are the directions which I did not explore during my PhD. I had no idea how I'm going to do that. But with more and more discussions, the corridor discussions, the discussions over coffee, and so on and so forth, allowed me to explore these directions, and we are collaborating now. So again, for early career researchers, please talk to your colleagues for guidance, for chit chat, for gossip, for rant about what is happening in the department, and for exploring new direction of research. With that, I would like to conclude. So today we discussed the need of trustworthy system. We talked a little bit about Manthan, the framework of Manthan, which is at the fusion of constraint sampling, machine learning, and formal methods. And finally, we talked about the direction that I'm exploring nowadays. Thank you so much.
Okay, thanks, Priyanka. Any questions, comments, anybody? You can ask until the mic comes. Go ahead, speak.
Oh, yeah. Thank you so much for that question. Yeah, when I emailed, and now I can imagine because I'm on the other side, he panicked. Like, what is happening with this girl? Why is she sending this me? But at the same time, he was calm and he called me for a meeting next day. We had a very long, thorough meeting. And he asked me what are the reasons why I am feeling like that. And then we had a long discussion, and I noticed because I was also one of his first PhD students, so he was also learning with me. And I noticed sudden changes in his own behavior after that meeting. And of course, he was giving me pointers how to improve myself. So that particular meeting was actually a turning point for me that I did not quit my PhD, very honestly.
Yeah, go ahead.
So, how do you, how has been your journey like finding mentors after PhD? Like, how do you find mentors currently?
How do I feel mentors currently? This is again a wonderful question. I think my journey, I will not be able to generalize this because during my PhD, I was able to visit a lot of places. I was able to go for workshop conferences, and I had a normally I'm a kind of an introvert girl as well, so I was interacting with a lot of people, so they knew me beforehand. And one advice again my advisor gave me is to be blunt and write to the people saying that I need you to be my mentor. If they agree, well and good. Otherwise, say thank you and leave. So that's what I did. I emailed a couple of faculties from IIC and IIT Bombay because they are not directly related to IIT Delhi, but they know Indian academia, and I bluntly emailed them and they agreed. So we have once in a 6 months meeting with them. I tell them whatever I'm doing. Of course, not like specific details about IIT Delhi, but in general, what is happening in my life, and they give me the pointers. This grant is coming up. You should mentor your student like this and that. So that's one way of finding mentorship. And the early career researchers, again, please find yourself a mentor. It is much, much, much needed. Another one, your advisors are always going to be your mentors. Any day, I just write to them saying that, oh, save me from this, and they give us advice how to do that.
So a couple of thoughts. One is on this last thing about how do I get into new areas. I thought Sam had some ideas.
Yes.
Send a PhD student to each one of them.
Yeah, but being again from the formal methods, I don't have that problem. I don't have students, that many students.
Machine learning.
That's how I have to wrap it up now.
And the second point, now I realize that ARCS should also have, mid-level, senior-level researchers talking about how they overcame all that. Otherwise, this kind of talks might scare people.
Yeah, there was one question.
Okay, there's one last question.
Hello, ma'am. Thank you for this. Here, ma'am. Thank you for this wonderful lecture. So, at what time you doing your masters from MIT Jaipur, right? So, at what time you realize that you have go to the you have to pursue the PhD, and when you were starting the PhD, so what subject you have to revisit currently I am also planning for PhD. So during so what should be your advice to the upcoming PhD aspirants who are taking up what subjects they should study just before going to the PhD?
Wonderful question. Again, because I entered into the IT during my PhD program, right? So, which is a very different situation to begin with. And the one thing that is, we have this illusion that we know it, but we don't. So, we have to take, I would say, almost all the courses in your area. I took discrete math again, linear algebra, abstract algebra, algorithm design, every single course again when I entered into IT, which was not the requirement. Requirement was very basic. You need to do 2 courses and get done with it. I used to sit into each and every course which I felt that I need to build my own background. So that is much needed. You can't be in the illusion that you know it all. You don't, and that's the harsh reality. As soon as you get into that, and you know that the first thing is to acknowledge the problem, and then you get to the solution. You need to acknowledge it first. So you need to do all the courses from as soon as you enter into the IT, sit into courses and do it.
Like we have studied social science in this our school, but during UPSC, if someone studies for UPSC, so we have to study all the 6 to 10 for UPSC. This I'm clearing and analogy.
Mm-hmm.
So you are saying before going to PhD, we have to visit all the subjects we have done in the bachelor and master's.
Of course, I would say, because you are doing PhD in computer science, right? So your area specialization will come in afterwards. PhD in computer science is you are master. You have this ability to teach this undergrad and master level course any of this, irrespective of your specialization area. Thank you.
Okay, thank you, Priyanka. Great kick off to this. I request Priyanka and Abhijit